In the cold vacuum of space, survival without protection is impossible. Not to mention the fact that even on neighboring planets, the conditions are unimaginably deadly. Each planet in our solar system offers a unique and horrifying way for an unprotected human to die. Today's journey is both mysterious and educational, as we'll step into the body of a hypothetical, somewhat careless explorer and find out what the final moments of life might be like on each planet. Today we'll visit the blazing daylight of Mercury, the crushing inferno of Venus, the suffocating cold of Mars, the depths of gas giants Jupiter and Saturn, and the frigid, stormy skies of Uranus and Neptune. Each environment presents its own nightmarish scenario. And as we travel through these hellish realms, remember, unlike them, Earth is a rare oasis where life thrives. So let's begin with the innermost planet where dawn breaks in a world of fire and silence. We begin with Mercury. Here, the unfiltered glare of the sun scorches the ground. Daytime surface temperatures reach up to 800 degrees Fahrenheit, hot enough to melt lead. There's virtually no atmosphere to diffuse sunlight or offer protection, so solar radiation strikes with full force. Stepping onto Mercury's sunny side, an astronaut would be subject to extreme heat and intense ultraviolet radiation. Immediately, all exposed skin would begin to sear and blister. The airless environment means no oxygen to breathe and no medium to transfer heat. Your shadow on the ground would be razor sharp. The sky remains black even at noon, since there's no air to scatter the light. In this near vacuum, the moisture on your tongue and in your eyes would also begin to evaporate, in eerie parallel to the conditions of open space. Within seconds, catastrophic overheating and asphyxiation would happen. Your first sensation would be a wave of heat across your suit and body. Even with insulation, cooling systems would be overwhelmed almost instantly. The landscape offers no relief, just a gray, moon-like expanse of rock and craters, burning under the rays of the sun. Mercury's weak gravity, about 38% of Earth's, might make you feel light, but the heat would be unbearably heavy. It's like stepping into a furnace. Within moments, your lungs would gasp in vain, since there's no air at all, and your vision would blur as your brain is starved of oxygen. You'd collapse within 10 seconds, burned and suffocating. Yet despite such extreme conditions, if you found yourself on Mercury's dark side, you'd freeze to death. A stark contrast. In the absence of sunlight, temperatures plummet to minus 290 degrees Fahrenheit. Now let's move to Venus. The environment here is often described as the closest thing to a literal hell. The atmosphere on Venus is extremely dense, about 92 times the pressure of Earth's, akin to being submerged nearly a mile underwater. The air is a toxic brew of carbon dioxide laced with clouds of sulfuric acid. Surface temperatures reach around 873 degrees Fahrenheit. Paradoxically, it's hotter than Mercury, despite being farther from the sun. Simply being on Venus means confronting heat capable of melting lead and zinc and pressure that could crush a submarine. As you descend through Venus's thick clouds, sunlight turns into an eerie orange glow. You might catch a glimpse of the barren, rocky landscape before the cloud cover swallows everything in thick haze. The very air is poisonous, filled with CO2 and nitrogen, and completely devoid of oxygen. Upon landing, a person would be crushed and roasted instantly. The pressure compresses your body with force strong enough to crumple a steel plate. All the gas pockets in your lungs and sinuses would be brutally squashed. And simultaneously, the immense heat scorches your flesh. Moisture evaporates and organs begin to fail within seconds. The corrosive air also contains droplets of sulfuric acid, but oddly enough, you won't be drenched in acid rain. On Venus, the acid evaporates before it hits the ground in a phenomenon known as virga. Still, that's little consolation. The ambient heat is so intense that even without acid, metals around you glow a dull red. Within moments, the visor of your helmet would soften and melt, and all exposed skin would char. The crushing weight makes movement impossible. Your knees buckle, your body compresses. Bones crack under the immense pressure. It feels like an elephant is standing on every inch of your body. The toxic, superheated air entering your lungs scorches them from within, and less than a second after exposure, you would lose consciousness. Your body, if it somehow remained intact, would be dissolved and incinerated into Venus's rocky soil. This is death by total environmental overload, pressure, heat, and acid working together to erase all traces of human presence. Flying past our blue oasis, we find ourselves on Mars. The red planet may seem appealing compared to Venus, but an unprotected human still faces a quiet, suffocating death here. The Martian atmosphere is extremely thin, less than 1% of Earth's, and composed mostly of carbon dioxide. Essentially, it's close to a vacuum. There's virtually no oxygen to breathe, and the atmospheric pressure is so low that liquid water would instantly boil away. The temperatures are also very low, averaging around -76 degrees Fahrenheit, but they fluctuate from a mild 68 degrees Fahrenheit at noon to a frigid -220 degrees Fahrenheit at night. Standing on the rust-colored sands of Mars without a spacesuit, the first thing you'd notice is the sky, a hazy iris color, and the horizon dusted and red. You wouldn't hear the wind in your ears, although Mars does have wind. The air's too thin for you to hear it. After a few seconds, the real danger sets in, and you cannot draw a breath. When you open your mouth to inhale, nothing happens. Due to the lack of atmospheric pressure, the saliva on your tongue and moisture in your lungs begin to boil, a chilling but painless hissing sensation in your body. You feel your skin tightening. While it won't explode, the fluids in your blood will begin forming gas bubbles. Oxygen deprivation sets in quickly. You have roughly 15 to 20 seconds before you lose consciousness. In that time, your body also begins losing heat. The Martian air is so thin it can't conduct heat very well, but the evaporation of moisture from your eyes and lungs creates a powerful cooling effect. Any exposed skin rapidly senses intense cold. Your vision narrows and darkens as your brain runs out of oxygen. You might feel a tingling sensation as blood vessels rupture under the pressure difference, or taste a faint trace of iron as capillaries burst. After about 30 seconds, you'll lose consciousness from hypoxia. Soon after, you'll die, quietly, in the brutal cold of this red planet. Your corpse undergoes sublimation. In such low pressure, your blood boils and your body temperature plummets. The frozen desert of Mars effectively mummifies what's left of you. The coroner's verdict? Asphyxiation and ebulism. Yet, compared to being burned alive, this death could almost be called peaceful. Perhaps Mars was more hospitable in ancient times, but today it is a graveyard for the unprepared, a place where the simple act of breathing becomes an unbearable torment. Let's move to the outer solar system. What would it be like to land on a gas giant, you ask? Falling into Jupiter is like descending into a planetary abyss. This giant has no solid surface. What appears to be surface from space is just the top of its cloud layers. As you enter Jupiter's atmosphere, you plunge into a world of colossal storms and crushing pressure. The upper layers seem deceptively gentle. Pastel bands of orange, white, and red drift beneath you, and you enjoy a brief moment of free fall under the dim sunlight. But the situation quickly changes. Jupiter's gravity, which is more than 2.5 times that of Earth, pulls you downward with increasing speed. The air around you thickens with hydrogen and helium gases. And soon you encounter winds beyond anything Earth has to offer. Jet streams moving at 400 miles per hour tear through the clouds. These winds will toss you violently as you descend. Massive storm systems, some large enough to swallow Earth, loom in the atmosphere. Perhaps you're falling into the heart of the Great Red Spot, a storm that's raged for centuries. In the dim light, lightning suddenly flashes across the sky. Jupiter's lightning bolts can be 3 times brighter than those on Earth, briefly lighting up those murky clouds. And thunder is replaced by an all-encompassing roar of wind and atmospheric turbulence. You fall deeper, and the pressure increases relentlessly. At a depth of about 30 miles, the pressure already exceeds Earth's by several times. Go further, and it's dozens of times more. The temperature rises too, from around negative 150 degrees Fahrenheit in the upper clouds to well above the boiling point as you descend. Your unprotected body is trapped between pressure and heat. The air becomes as dense as water, treating you not like a skydiver, but like a deep sea diver. At 10 to 20 atmospheres, human flesh compresses and the lungs collapse. Any hollow spaces in your body, sinuses, inner ears, they rupture under the strain. As the gas around you thickens, your body is compressed into an even smaller volume. Now the world is completely dark. Sunlight cannot reach this depth. The only illumination comes from occasional lightning bolts and the eerie glow of distant electric discharges. Your bones begin to crack as the pressure climbs into the hundreds of atmospheres. Ferocious winds tear your body apart, and eventually the combination of pressure, heat, and mechanical stress vaporizes you. Your molecules blend into Jupiter's vast atmosphere long before you ever land on any kind of surface. Consider this. Even robots have a hard time surviving Jupiter. What is there to say about humans? The Galileo probe, which entered the planet's atmosphere, was destroyed by its pressure and heat. For a human, there's no hope except for complete dissolution in the belly of the solar system's largest planet. Our journey continues onward to Jupiter's younger brother. As we pass by Saturn, one cannot help but be mesmerized by its majestic rings, countless icy particles sparkling in the sunlight, encircling the planet in broad bands. But this breathtaking view hides a deadly danger. Far from the sun, Saturn is an extremely cold world, with temperatures at the top of its clouds reaching about negative 288 degrees Fahrenheit. If you were to enter the planet's atmosphere, your fate would resemble that on Jupiter. Eventually, you would be crushed by the frigid, dense haze of hydrogen and helium. However, space around Saturn is nearly as unforgiving as the planet itself. The rings are made up of water ice fragments ranging from tiny grains to boulders several yards across. These pieces orbit the planet at enormous speeds, tens of thousands of miles per hour relative to Saturn. Now, for an unprotected human, it's like the storm of high-speed bullets and cannonballs. Ring particles streak past, glittering. At first, the tiniest ice grains pelt your suit, kind of like searing snow. Then larger pebble-sized shard strikes it, and at such high relative speeds, even a pebble hits with explosive force. It punches through before you can even register it. More debris follows, a hailstorm of ice and rock slamming into your body. A fist-sized piece could tear off a limb. A large boulder could blow you to pieces. In mere moments, you're riddled with holes. Your blood, exposed to the vacuum, boils and freezes simultaneously, scattering the rings with shimmering crimson ice crystals. All around is an eerie silence, since sound doesn't travel in a vacuum. As the remnants of your body continue to orbit along with the other particles, becoming one of them. The seventh planet, Uranus. It's often called an ice giant, and with good reason. It holds the record for the coldest planetary atmosphere in the solar system. Temperatures in the upper layers can drop to 49 Kelvin, approaching absolute zero. An unprotected human here faces almost instant freezing. The atmosphere contains no oxygen and is composed mostly of hydrogen and helium, with traces of methane that give the planet its blue-green tint. Now, there are likely clouds of ammonia and hydrogen sulfide too, but highly toxic. And while Uranus doesn't have the crushing pressure of Jupiter or Saturn at its cloud tops, the atmospheric pressure still increases with depth and eventually exceeds that on Earth. But there's no need to worry. You'll have died long before pressure becomes an issue. The main killers on Uranus are cold, toxic air, and wind. Yes, there is weather here, astonishingly fast winds reaching speeds up to 560 miles per hour in some regions. Imagine a freezing hurricane made of poisonous gas. As you fall through the upper atmosphere of Uranus, sunlight becomes barely perceptible. The sun, a tiny, distant speck. You're enveloped in a pale bluish twilight. The temperature plummets rapidly. Almost immediately, all moisture on your body and your eyes, nose, and mouth freeze. Thin layer of frost forms on the inside of your helmet's visor. A single breath of the planet's air could be fatal. Your body would convulse from the lack of oxygen and simultaneous poisoning. Within seconds, you would lose consciousness from hypoxia. If by some miracle you stayed conscious a bit longer, the cold would pierce through you. Death occurs in less than 1 minute. Your body would continue falling until the increasing pressure shattered it into thousands of icy fragments. Once again, our hypothetical body is brought back to life, ready for another descent. And this time we find ourselves on the very edge of the solar system. Neptune, a beautiful blue giant, home to the most ferocious weather of any planet. This planet's atmosphere is eerily cold, only slightly warmer than Uranus, about 55 Kelvin at the cloud tops, and howls with supersonic winds. Wind speeds here reach up to 1,300 miles per hour, making them the fastest sustained winds in the solar system. Now, for an unprotected human, this place offers a swift, brutal, and disorienting death. The distant sun provides almost no light. You're immersed in perpetual dim twilight, practically darkness. As you descend into the upper layers of Neptune's atmosphere, you may glimpse a massive storm system, perhaps the famous Great Dark Spot, once observed by Voyager 2. Almost immediately, you're overwhelmed by terrifying winds. The thin upper air quickly thickens as you descend, and the hyperstorm slams into you with full force. The winds exceed Mach 1, moving at the speed of sound. In these conditions, the air itself becomes a sandblasting weapon. Tiny frozen methane particles are turned into shrapnel, shredding everything in the path. You're tossed like a rag doll, helpless in the storm's grip, spinning in every direction. You lose all sense of orientation. The cold cuts through you, but the trauma from the wind might outpace the sensation of freezing. At least in Neptune's upper layers, pressure doesn't immediately become fatal. You remain conscious a little longer than on Jupiter, but the savagery of the environment quickly ends that. In seconds, any form of protection is destroyed, and bare flesh meets hypersonic, icy air. Your skin is then torn away, your flesh scraped to the bone by crystalline ice. Eventually, your remains are scattered through Neptune's endless storm. At last, after journeying through the myriad of deadly environments of the solar system, we return to the only place that has ever welcomed us. After facing the lethal extremes of other planets, Earth suddenly feels like a gentle haven. And indeed, it is the perfect world for human life. Here, the atmosphere provides optimal pressure, a breathable mix of oxygen and nitrogen, and a temperature climate. We have liquid water that doesn't boil away instantly, a protective ozone layer shielding us from harsh solar radiation, and temperatures that mostly remain within our body's survivable range. Standing on Earth's surface under warm sunshine and blue skies, you can breathe deeply and enjoy a new day. It's telling that on every other planet we visited in this thought experiment, death was almost immediate. While here, life not only survives, but thrives. The contrast is profound and humbling. A gentle breeze, warm sunlight, and flowing water on Earth. These are gifts of a universe that is otherwise unimaginably hostile. So next time you step outside and you feel the air fill your lungs, remember just how extraordinary that truly is.